So today's lesson is going to be on special cases when factoring. So when you look at special cases when factoring, the two types are perfect squares and difference of squares. Perfect square means that it's a factored square of each other, and difference of squares is two brackets with different symbols but with the same numbers, and you'll know what I mean by that as we move further into the video. So a shortcut for perfect squares is a plus b squared. So that is how the end result should look. And this is equivalent to a squared plus 2ab plus b squared. And difference of squares is a plus b, a subtract b, which is equal to a square minus b squared. So let's begin with an example. So when we have x squared plus 8x plus 16, you have to check if you could square this and if you could square this. So x squared can be squared, and this would be 4 squared to equal 16. So this could potentially be x plus 4 squared. But you have to check, well, this is an 8, and to see if this is equal, then you have to do 2 times a, which is 1, times b, which is 4. So 2 times 1 is 2, and 2 times 4 equals 8. And positive 8, so this is right. And if you just wanted to check that, all you had to do was expand. So it would be x plus 4, x plus 4, x times x equals x squared, x times 4 is plus 4x, 4 times x is plus 4x, and 4 times 4 equals 16. When you collect like terms, x squared plus 8x plus 16, and that gives you your original equation, which we started off with. So now moving on to difference of squares. So difference of squares could look something like 2 squared minus 9. So when you have this, you have to see, well, can this be squared? Yes, that would be x. And this could be squared, because it would be 3 squared. So since you have that, it could potentially be x minus 3 and x plus 3. So all you have to do now is expand and check. X times x equals x squared. X times 3 equals 3x. Negative 3 times x is negative 3x. 3 times 3 equals negative 9. If you collect like terms, these two cancel out. So it's x squared minus 9. And this is equal to that. So there you have it. So now, if we want to show another example, say 4x squared plus 20x plus 25. So you have to see if this can be squared, which would be 2x, and this would be 5 squared. Well, now you have to check, will 2 times a times b equal 20? So 2 times a, which is 2, times b, which is 5. 2 times 2 is 4. 4 times 5 equals 20. So you should be good. So 2x plus 5 squared. And that is your answer if you want to perfect square. And you can always check by just expanding. So now moving on to another example of difference of squares. So if you had 81x squared, x squared minus 64y squared, this would be 9x squared, and this would be 8y squared. So since you know that it should be a squared minus b squared, we could just do x minus, 9x plus 8y and 9x minus 8y. And all you would have to do to see if it was right is you would have to expand. So 9 times 9 would be 81x squared. 9 times 8 would be 70, negative 72 negative xy. And then 8 times 9 is positive 72 xy. And then that would be negative 64y squared. So if you want to collect like terms, these two would be canceled out because it's negative and a positive with the same value. So the final answer would be 81x squared minus 64y squared. And this is the same as this. So now you know that you did all of your steps right. So this is how you do perfect square and difference of squares, and I hope that helped. Thank you.